Hi, welcome back. So this is another video Adam training derived variables and SDTM variables. So the part number 7. So myself, Ali Sheikh, I'm the consultant at Tile Optima. So the introduction part, the TRIS training module covers information from Adam implementation guideline version 1.1, section 2.2 traceability, and section 3 standard Adam variables and Adam model 2.1. So if we check section 3.1.1 traceability, so this information will be presented there. So the required reference materials, you will be having Adam model version 2.1 and version Adam IG version 1.1 acronyms reference and CDISC Adam terminology. So the table of contents, so the variables in Adams, core variables, SDTM variables, source dataset variables, and example implementation, the practical application of the Adam variables in a clinical datasets. Okay, so if you check the next ones, the variables in Adam. So the Adam methodology requires the standard variables to be used for specific purpose, even when content copied from the SDTM variables. Okay, so they are the methodology. It has to be required if you need to create the Adam datasets. Okay, so basically it facilitates the transparency, which is as an essential component of the building confidence as a result or conclusions. So to understanding the relationship between the analysis results, the Adam datasets, the SGM data, or the data collections instrument, establish the path between the elements and immediate predecessors. Okay, so any variable in Adam dataset whose name is the same as the SDTM variable must be a copy from the SDTM variable, and its label, meaning, and values must not be modified. Okay, so the core variables in Adam, so there are three major core variables. Obviously there are three only. The required variables must be included in every Adam dataset. So study ID, unique subject ID, and expected variables should be included unless specifically not applicable. So the param cd, aval c. Okay, so permissible used when needed to support analysis. The time point variables, derive flags, and indicators. So when needed to support the analysis, so we these three are the core variables in Adam. So SDTM variables in Adams, the key principles. SDTM variables may be copied directly into Adam datasets. So variable names and labels must remain unchanged. As I mentioned before, the labels and names should be remains unchanged, and the SDTM variables you can directly copy it from the directly copied into Adam dataset. Ensure the clear traceability back to source data. So use it when original values are needed for analysis. So the traceability requirement, Adam requires the clear path for analysis results back to the submitted SDTM source data. This is a fundamental regulatory expectation. So here what they're saying, the SDTM variables should have, it has to be copied, like if they have copied, it can be copied directly from SDTM variable into the Adam dataset. So the name should and the label should not have to be changed. So it has to remain unchanged. So you have to go back the traceability, like go back and check the source data. So make sure the clear traceability has to be present. Okay, so you can mention in the metadata as well. So SDTM variables examples. SDTM variables required for Adam vital signs dataset, analysis dataset for vital signs. These variables provide direct traceability from the analysis dataset back to the original SDTM data. So you can see here in this box, you can see vs dot vs dot vs dot. This is the traceability. You can clearly see that this variable coming from the SDTM. So you can also have the methodology, the predecessor. That is the methodology. So these variables, it goes to the ADVS datasets. Okay. So the source dataset, for the purpose, the source dataset variables documents the original of analysis values when they are derived from multiple sources or transferred into complex ways. Facilitate regulatory review, support reproducibility, and maintain data provenance. So these are the main purpose of the source dataset variables. Okay, the source dataset variable specifications. So the source domain, source data, character, and which domain is coming from, the source domain, and the source variable, SRC variables. So which variable is coming from that. So these are the three variable names. So it gives the source dataset variables, like source sequence. So most of them are, three of them are permissible variables. If the source dataset is supplementary qualified in SDTM, source domain will contain of the value or domain in subcall So for suppose source variable will be populated in the qnum. So the source domain will be considered in our domain in the supplementary qualifiers, and the source variable will be considered as a qnum value. So the source dataset variable implementation. Identify the source. Source domain contains domain name, example, vital signs. Or Adam dataset name that contains the source value. Or source variable identify the specific column name for the source domain or dataset. And source sequence provides the sequence number of the specific record in the source dataset. So these variables create an unambiguous link. So there should not be having any confusion between the each analysis value and source data point, maintaining the full traceability throughout the analysis purpose. Okay. So for example, here if the BDS dataset it relies the data both LB and AE domain to define a val value, then all the three variables are needed for traceability. Okay. So here the variables in Adam, so following standard naming conventions ensure consistency across studies and enables efficient analysis for clinical trials. Okay, so let's continue with this part here. So the variables in Adam naming conventions, Adam implementation guide adherence. So variables listed in Adam IG should be followed. Necessary variable is similar in concept to what is presented. SDTM variable integrity. Variables from SDTM should be an exact copy of the identical name and label and values. So we'll be have analysis variable standardized. Analysis variable related oval C are prefixed with A. So A analysis A indicates analysis, and variable pair convention. Primary variables don't require a suffix while paired with use C for character and N for the numeric. So these are some naming conventions how the variables represent and what is the use of it. Okay, so if it is A represent for analysis and C represent for character, so this is kind of naming conventions. So if you check here general conventions, so the W represent with the variable digit 1 to 9. So xx represent like xx represent the specific period like NR01 flag or TRT01P, two digit like 01 to 99, and grouping categorization analysis criteria. So y represent the grouping, so like age gr1 age gr2, so it should not have 01 here, so it should be like just one character, one numeric value. So z represent the two digit zero pattern, so it is an 01 flag. The common suffix n is numeric, c is the characters, and dtm will be the date time, the flag, and the group category and the relative dates. The character SDTM to numeric Adam should be named SDTM plus n. So dm. So for example, here you see dm.sex, and when you come to the Adam, it becomes sexn. So the numeric format of the sex variable. So BDS with multiple domain sources. So here we have param, avalc, source domain, and the source sequence, source variable. As I mentioned, this is param, right? So for these subjects, my event of interest, and aval is the value of that result. And where exactly we get this information? We get this for this domain AE. And what is the sequence of this record? 34. And what is the variable AE decode? So like that, you can able to mention for the source dataset examples. So variables in Adam, order of the variables. So identification variable, subject identifier. So study ID, unique subject ID, and record identifiers, a sequence, param cd. And then topic variables, the core analysis variables, aval c, their derivatives, change, percentage change. Then timing variables, analysis relative date, analysis study date, and the dates, and a visit and visit information, and then grouping treatment information TRT01P, TRT01, and other classification variables. Then we'll be having the supporting variable, the source domain, source variable, source sequence, and metadata. The consistent variable ordering improves the dataset usability analysis of efficiency. So for any kind of PDS data structures or any Adam data structures, you can clearly memorize this pattern. So identification variables, topic variables, timing variables, grouping variables, then supporting variables. Like that, you can mention easily in case if someone is asking in the interviews. Okay, so the variable in Adam, the population flag. So we'll be having Adam population flag correspond to SDTM supplementary qualifiers, but followed standardized naming conventions. So you'll be having a completed population flag, full analysis set population flag, intended treatment population flag, per protocol set flag, safety population flag. Okay, these are population indicators. So variables in Adams baseline flags. HDTM baseline flags represent hyphen hyphen baseline flag in domain variables. So like say VSBLFL, LBBLFL, the baseline flags. So value limited to Y or null, cannot have multiple baselines. So either you can have Y or missing. Cannot have multiple baselines. You use it primarily for data collections. In Adam, when it comes to Adams, you will be having base flag X, where X can be used to identify multiple baselines, can have a study specific extension, support multiple baseline definitions, use it for analysis with the corresponding base type variables. So some dataset will be having the multiple baselines for the subjects. So for the parameters, so you will be considered based on the treatment. Like for example, one subject have double blinded and another subject have open label. Like the same subject will be going to open label, so there should be two different baselines there. So on the time you have to pop up the base type, which baseline you have considered for the analysis purpose. So here this is the pattern, the screening. Original values collected before randomizations, and then baseline 1 pre-dose values, then treatment, on treatment assessment compared to baseline, and baseline 2 mid-study pre-baseline flag. So example, the single domain BDS data structures. So you see here, as I mentioned, this is also in the LB dataset. So the param will be the total cholesterol and what is the character result 210, and the source domain will be the LB, and the source sequence of that record is 19 record, and source variable will be the standardized result numeric format, and the sequence LB sequence would be the 90 because this is the same record, right? It's getting from the same record. So the traceability features, the source domains identify original SDTM domain, and the source LBSTR, the source variable, and the sequence, the original sequence numbers, and domain specific variable retained. Okay, so analysis features standard parameter naming, param, consisting values representations, ready for statistical analysis, maintain full data provenance. Okay, so this is something BDS with a single HTTM domain source. So examples for the ADVS derived variables, HDTM VS domain, source vital signs data with original measurements and units, derivation process, standardizations of units, calculation of changes from baseline, and analysis ready vital signs with derived parameters and categories. So these are some variables coming from the ADVS. So they are related to the. So you will be having the vital signs, HDTM domain data variables, and also from some of the derived variables, and analysis ready, derive, and categorization. So they will be having the category, criteria, and evaluation results. So you have these variables, you have to be derived. Okay, so some of them are predecessor and some of them derived variables. Okay, so yeah, that's it for this video. Thank you so much for listening.